Hey everybody. So my name is Matias Niemela. I'm going to talk about AngularJS 1.3 and just how to put together a web application using it and some of the advanced new features that come along with it. So about myself, I was born in Finland and I've lived in Toronto for 15 years. For the past 2 years I've been a core developer on the AngularJS project. And on a weekly basis, I'll fly through about 4 different programming languages, coding stuff from JavaScript all the way to Clojure, doing stuff in Dart, and so on. My website is yearofmoo.com, and my Twitter handle is @yearofmoo. So I've been building websites for over 10 years, and in the past 10 years, I've noticed there's a huge difference in terms of what's out there, right? And let's talk about these websites that have been coming around in the past few years and like where the trend is going. Well, we have web applications and we're trying to mimic what happens on the desktop in an application environment, but we're using web technologies to do that. And if we were just to use regular CSS, HTML, and JavaScript, it kind of wouldn't be enough because that technology is not entirely designed to do these kinds of things. But that doesn't stop bright developers, engineers, inventors from crafting these tools together to build websites that can leverage applications that work on a computer. So that being said, where is the technology heading? So we're heading more and more towards frameworks and tools and technologies that have a solid basis, and that basically means MVC frameworks. So an MVC framework such as Angular, such as Ember, such as Knockout, allows us to basically organize our JavaScript code, our HTML code, and our application structure in a predictable way. And what we're doing here is we're separating the data from the template, which is the view, the data is the model, and the controller, which is the logic for the application, to 3 distinct areas. And at the same time, that lets us use less HTML, less JavaScript code to do more, because the framework takes care of most of it. And while we're doing this, we're kind of separating the data from the structure of the page, which means we're separating the front end from the back end. You end up having the back end server, which can run on Rails or PHP or Node, from the front end code, which runs in Angular, being completely separate from each other. So of these MVC frameworks, Angular is obviously one of them. For those of you who haven't used AngularJS before, the idea here is that we embrace HTML. We allow HTML to do more than it was designed to do in browsers. And we use dependency injection to facilitate code reuse in the application, and routing and structure in the application to make Angular do a lot more than you can think it can. Finally, Angular comes with a lot of HTML components, which are extra HTML tags, which can really make your application do a lot with very little code. So why should we use Angular? Why should we care? The point is that it's backend agnostic. Once again, the backend's separate from the front end. And since it's a framework, testing becomes easier. Testing is encouraged because everything is organized in a proper way. And it is one of the leading MVC technologies. So if you're worried about being brand new and you don't know where it's going to go, it's been battle tested. There's a lot of big websites that use it, and so on. So now that the backend isn't doing as much as it did, so like 10 years ago, when I was building websites, when I was first learning them, PHP was kind of the way to go, right? And back then, PHP did all the templating stuff, and all the browser would do is just download the HTML code and display it to the user. If you wanted to have extra interactivity, you do this fancy thing using JavaScript, like a highlight or a fade or a slide. That's really it. Nowadays, it's the opposite. So you've gone to having a FAT client and a fin server, where the server, all it's doing is giving data to the browser. It's like, here's a JSON API. We're going to expose this data, and the browser is going to download that data and build the UI for us. So this kind of contradicts the old school method of building websites with dynamic websites. So if you were to build WordPress websites, or you were to build websites that render the template on the server, that's what the difference is. In this case, the data is not going to be tied in with the HTML. The data and the HTML are separate. So since our application is running with JavaScript. Does that mean that a search engine can render it? If we were to have a search engine render JavaScript code, does that mean that they can do it? Well, it's close. You know, search engines like Google and Bing are getting closer to doing this. They probably can't do it 100% yet. However, if you want your application to work on SEO, it's just a matter of finding the recipes online that explain how to do it, and there are. So if this interests you, take a look on Google for AngularJS and SEO. Okay, finally, what about older browsers? Well, IE9 and above for 1.3, IE8 and above for 1.2. We can't support every browser. The older browsers don't really have good JavaScript support, but browsers nowadays are getting more and more, they're improving much faster than usual, and as long as we keep up with the most modern browsers, then you should be okay when building these applications. Okay, so let's start with the basics of Angular. So with modules and expressions, we're sort of building the application structure. The expressions are going to be put in the template to display data. Dynamic templates are going to allow us to build a page only using HTML or using very little JavaScript code. And controllers and scope are going to hold the data. So this is what an Angular application looks like. Here we have AngularJS being loaded in. We've defined a module, and then we've added the module to the page. But so far this doesn't do anything. This is what it looks like for displaying data on the page. So we have a name and we have a getAge value. And so far, if we wanted to do this on a server, what would happen is the server would run through all the expressions, print into the data into the HTML, the client would download it. But that data is kind of static, right? It's already been downloaded, it's not going to change. This lives on in the browser. So that means that if any of these values change in the browser, then the page will get updated instantly. So let's, for example, try this out. I'm going to open my favorite editor. And so, can everybody see this? Okay, cool. So let's paste that in. Whoops. So we have here two expressions that show data. This is a function, but we're not going to get to the JavaScript code yet, so I'm just going to put this as a variable for getAge. But if I define a value here, if I say that name is equal to Matias, age is equal to 27, you can see that when we show the website, you can see that the values show up. But nothing crazy is going on, right? It's just rendered into the page. I'm better off using something like PHP because this JavaScript code looks complicated. What's so special about it? Well, what we can do with this is we can make dynamic templates. We can have bits and pieces of the template change with only the data changing. So in this case, if we wanted to make a message show on the page, so let's get rid of this code. And let's make it so that when we click on a button, you can see that the message shows and it hides. So I'll give it a moment to load. So if I click on this button, the message shows. And then you can make it so that the message toggles, so show messages on and off. And you can actually see that we made an interactive piece in our template without having any JavaScript code to power it. But this is kind of boring so far. So how can we make it so that we can actually change data in JavaScript and have it reflect into the template? We can use a system called the scope. And what the scope does is it's kind of like the memory of an application. Whenever we change data on the scope, the values will update on the template. So let's copy this JavaScript code in. Let's put it right here. And here, what we had before, so let me copy over the code from here. Now we're using the memory of the application. So in this case, we're using the root scope. We're putting data on the root scope, like my name and my age, and now we can show it into the template code. So let's get rid of this right here. So let's see, yeah, I left a semicolon there. Okay, cool. But what about if we wanted to actually have it so that we have specific areas of the application to only show data or to have interactivity in there? We can use stuff called a controller. And what a controller will do is it will scope out one part of the application to have its own data. So if we had a user controller we wanted to display the name and the age and stuff like that, we could put that into its own controller. So let's say we take the controller here. Let's replace this code. And let's put the controller right here as ng controller, user ctrl as user, and now we have the username and the user.getAge. Same idea here. Really cool. Okay, well, it's really boring so far. I'm just taking data in JavaScript and putting it onto the page. But what if we wanted the user to be able to interact with the application? Well, with Angular, we have a system called two-way data binding, where what happens is the data from the user interacts with the data of the application. And when the data on the user side changes, it updates the data on the application. When the application changes, it updates the data the user side. So here, if we use input field, and we say that the input field is going to listen on user.name, if I hop in here and I start changing the value for user.name, you can see that the template code and the JavaScript code updates automatically. So let's say that I had a function to check this out. I could say this.alert name, and I could just do alert self.name, make self equal to this. So here I could have a button for that, just to prove that the data changes in the JavaScript world without me having to manually update it. So if I do user.alertAge, you can see that whatever I type in here, oops, did I forget something? Alert name, my mistake. You can see whatever I type in here, the data updates accordingly. So I've built an interactive application without really any JavaScript code aside from the data in less than 30 lines of code. Really cool. So we saw that I passed an ng-click, and ng-click handled the click operation. So you might be wondering, well, websites back in the day, they had on-click and stuff like that. Like, are we going backwards? Well, no, what we're doing here is we're changing the data around in the application based on what the user is doing. So if I were to read code like this and see that, oh, a click operation is going to happen, and oh, there's an expression in the template, I'll be able to understand the code far easier than if I were to look at somebody else's JavaScript code. So we're using the template as a script to describe the interactivity of the application. And what we can also do is we can take data and we can sort of represent it in a different way. So for example, here we have a controller that's going to show today's date. We can use a filter here to format the output of the date. So what we're really doing is we're using the template as a mechanism to display information to the user. Another good use case is repeating data. How could I show a series of values on the page in HTML? Well, HTML isn't designed to repeat a series of div elements on a page. You'd have to use JavaScript. But with Angular, what you can do is you can use ng-repeat in this case. So if we wanted to display a series of numbers, we copy this code right here, we put it into the application. And now if we display the series of numbers, oh, sorry. I know it's too fast. I've seen the code way too many times, so I jump back and forth. I'll get to the code in a moment. Just need to add, let's see what's going on here. Oh, that's right. My mistake. So I'm in an application right now that can add or remove numbers on the screen. The code, once again, to do this is we describe the numbers, we set functions on the controller for getting the numbers, we have a function for adding and a function for removing. And then to put that controller code into the template, what we do is we set a controller, and then we can have add, remove, and show the numbers. So we're embracing HTML, we're adding more features into HTML to display data. But you might be wondering, how does the browser update it automatically? Because I haven't had a callback that tells, Angular, hey, update the page, or hey, there's new data on the page. How does it know to update itself? Well, since we're using the special HTML stuff of ng, which is the Angular prefix, like a ng-click or an ng-repeat, or we're using a scope to display data, Angular is aware of when new data comes in. It's aware when the user interacts with the page. So you don't have to have this crazy callback stuff like render the template or update the data. Angular will do that on its own. And this is known as a digest cycle. So what happens is it takes the old data in the model and it compares it to what's in the view, and it says, has anything changed? Is there any data I need to update? And when that it has changed, it will update them directly. So what are some of the more advanced stuff? So far we have a really basic application. We haven't done much. Well, what we can do is we can use directives we can add extra components to your application, for example. And the dependency injection stuff is when we want to have code that goes into other parts of the application. And we're going to take a look at routing and unit testing. And after that, we're going to look at some of the brand new features in 1.3. So let's talk about directives. We saw ng-repeat, we saw ng-if, we saw stuff like that. Those are all components that don't exist in HTML, right? So what Angular did is it created these components. These components are known as directives. So let's say that we want to have a HTML tag called say hello, that when you click on it, it would say hello. If I copy this code right here, and I'll explain what it's going to do in a minute. What's happening with this code here is we're creating a HTML tag called say hello that when you click on it, it will do an alert message. It's not super helpful, but the point is that click here to say hello. The point with this is that we created an HTML component. Just like that, we created a new tag that does something. And what you want to do is you want to make your HTML very descriptive. You want it to have all these cool features, but have really easy to understand tag names and make it really clear what's going on. All right, well, what if we wanted to make our own tab system like this? We wanted to have a series of tabs on the page so that when you click on a tab, it highlights it or it calls a function to update something. Well, tabs doesn't exist in HTML, so we'd have to use a directive to create that. We'd also have to create an inner directive to communicate with the parent directive to tell it, hey, there's a new tab and I've been clicked on. This is what the code looks like to set up the parent tabs. What we're doing here is we're setting up these controller functions to register new tabs, and then when you click on them, it's going to call select message, and so on. And then we have another code right here, which is going to display each of the tabs, or it's going to have an individual tab, and then it's going to set the event listener to update itself. Let's copy this code again here. And let's copy this code here. And so we have the top level tabs and we have the bottom level tabs. And now let's copy the HTML code to represent the tabs here. And let's set some styles for the tabs so that we can see how they look. So we say display block. So I'm using, with directives in Angular, you can use either HTML elements or you can use them as attributes. So I could go like this, for example, and do div tab like this. I choose to put HTML elements because it's a little bit more clear what I'm trying to do. So I'm putting the style for both of them. So we have a tab element, and the tab element, we're going to say display inline block, and let's set background to red or black and color white, and padding 10 pixels. Let's also set it so that when you click on it, it's going to set it to an active class where the background is going to be red when clicked. And then finally here, there's a tiny little bug in the code, and it's going to make it so that for each function tab. And finally, I need to load in jQuery. Let me just quickly get that from here. All right, so I'm going to load in the jQuery code. And now, what we've done is we created a series of tabs that when I click on them, it just automatically changes the class name to it. But the cool thing with this is that I've created the code that works with the HTML element, but the underlying HTML code is very simple. I can use this component, put it at other parts of my application, and it works as expected. This is what directives do in Angular. This is why they're so powerful. And this is why the HTML component works so well with the application. Finally, stuff like this is where websites are heading. We're going to be using web components in a few years. We're going to have something called the shadow DOM. We're going to have custom HTML elements in our application that do all this cool stuff in the background, and then you can customize them in your code. So this mechanism is going to be happening with newer browsers, and Angular already has it in its own framework. So now that we understand how directives work, let's talk about dependency injection. If we had one piece of code in one part of the application and we wanted to put it into another part of the application, how could we do that? Well, with dependency injection, we can say take in one service that's defined in one part of the application and throw it in. So right here, for example, we're taking the root scope, which is the global memory of the application. We're like, give me an instance to the global memory. I'm going to put some data in there. Or give me an instance to this particular function that I need. Or give me an instance to a constant. Now, you might be thinking, well, what's the point? Why don't I just have floating variables and floating functions around in my code? And the point with this is that if you were to test this code out, you can mock things much easier. So we'll take a look at that in a moment. So one particular service that we would like to inject into our application is HTTP. So with HTTP, we can query a backend to get data and put it onto our page. So in this case, we're asking for the HTTP service in the controller function. We're like, give me an instance of HTTP. And then we're going to query the server to get the details and then put them onto the controller memory. So for example, if I copy this code over and let's keep all the tab stuff because we'll need that later. But let's say we have a controller for users. And we're just going to query a users.json file and put that on here. So here, if I were to have div ng repeat user in users, what do I call it? Entries. We're going to display a user. Okay. So let me just see if I've correctly done this. Let's do a console log just to see that the data got downloaded. Okay, yeah, so you can see the users got downloaded. And these are put at, oh, that's why. This has to be self. So we can see that the users got displayed in the page. All that we're doing here is we're just downloading it from a resource. We don't have to tell the template to update. Angular knows that when new data comes in with the HTTP service, that the template's going to update itself automatically. But you might be wondering, what's this success method? Well, what Angular makes use of is it makes use of these things called promises, where whenever anything asynchronous happens, it returns an object that has callback methods. So when the promise is fulfilled, it's going to run a function to update the page. So in this case, we have a success function, and we have an error function. And what a promise will do is you don't have to use callbacks in your code. You don't have to handle the callbacks in one particular piece of code and then call them when they're ready. So what that does is you don't end up having code that looks like this, where you have one callback instead of another callback. You have this Christmas tree of JavaScript code that's really hard to test, and it's just messy. I think the most I've seen is like 5 of these, and it's like, okay, our application works, it's so cool. But no, like when I was studying computer science, they told me you shouldn't have more than 3 if statements in your code, like nested if statements. I'm like, okay. But then I saw JavaScript code, and I'm like, oh no, this can't be right. So what the Promise API does is it allows us to chain things using this convenient, consistent API. So we're like, this is what happens when this is done, this is what happens when that is done. So the success function that we had here, this function right here is just another name for the then function in Angular. But the idea here is that we can have multiple functions get called when a particular callback is ready. Okay, so let's talk quickly about routing then. If we wanted to have a particular URL route to a particular page on our Angular application, we can have the root URL, we can have /users and stuff like that. Well, to make this work, we added a module called ng-route, and then we define a route like so, where we have a controller, and then we have the template URL, and that sort of specifies what the page is. So in this case, if I want to have a home controller, and I wanted to have, say, the users controller, we can add this in. So I'm going to add in the home controller, and then I'm going to make another route for the users controller. So we have users, ctrl. So we've already defined the users controller. Now if I go into the home page, you can see I've already defined the HTML for the home page. Welcome to the home page. And then I've defined for the users page, I'm going to have welcome to the users page, but I'm going to copy over the code that lists the users on the page. Oops, wrong file. Here we go. But how can I actually put those templates into my application? Well, if we use this special HTML directive called ngView, all the templates and all the controllers that are associated with the route are going to be loaded into the page. So if we copy and paste this over, I've done a lot of copying and pasting today. So you can see that we have home and users, and looks like it's not downloading Angular properly. I also need to download Angular route. Oh, is my connection down? Looks like it is. Oh, there we go. Now it's back. So now, since I use another module called ng-route, I add that into here, which is going to use that module. And now we have the home page. Oh, it did get loaded in the home page, which is kind of strange. Oh, sorry, that's why. This has to, sorry. So here we have /users. So here we have a home page, home controller. We need to define that as well. So we have our home page, we have our users page. But what if we want to make the tabs work as links for our application? So if we got rid of this navigation here, and since we can use these directives as regular HTML elements, we can make this tab as the home page, and make the other one as the users page. So we have home and we have users. So that's how you do routing with Angular. Now what about unit testing? We can use Jasmine or Mocha to test parts of our application out. And we're going to use something called Karma to test out our code in multiple browsers. So you would install Karma using npm, and then when you call Karma start on your code, you end up having output like this, which looks like, why does it get smaller when it goes larger? Okay, so here we have a console that tells us that, okay, the browser passes in Chrome or fails in Firefox, and it tells us which tests pass and which tests fail. So if we wanted to actually test out our Angular code, we would use Jasmine, and we would have a test like this. We're describing a test. It's going to particularly test this feature, and we're placing expectations in our code. So the code behaves in a certain way. With Angular, when we include it, we can tell it to load up a module. So the my app module that I had loaded up in the application is running, and then we use inject to inject key pieces of our Angular app. So if I were to make the hello service, and the hello service would return a translation of a text in whatever language you have, I would inject it here, and then I could run an assertion on that code. If I wanted to test out a directive, for example, if I wanted to test out the hello service or hello message directive that we created, all that I would do is I'd compile the HTML, and then I would use the digest, and then we would check to see if parts of the HTML code have been updated as follows. Now, I'm not expecting everyone to understand this, which is fine, but what I'm trying to emphasize here is that the testing code works so well with the inner code of Angular that it's so easy to hop in there and test key pieces of code out. And that also facilitates mocking in a really cool way, because what you can do is you can have a particular service, something like root scope or some other service that you define, and you can override it in the test, and then you can stub it to return false data. Another really cool thing with Angular is that you can debug things much easier. You just hop into the console and then you use $0. So the code right here that I have for the tabs, if I hop into here and I hit $0, that's going to show me the particular tag that's selected. And if I do Angular element $0 and then I do scope, I can see all the properties of the data on the scope for that particular tab. That's how you would debug an Angular app. Another thing to look into is protractor testing. I'm not going to go over it in this talk, but the idea here is that you would describe how a page should work in a test. You describe that we're going to go to the page and examine the title or examine an HTML element, and then you can check to see if certain properties exist on the code. So what's happening here is we're going to the index page, we're checking to see if there's a listing property and if there's an empty listing property, and we can examine all the properties on the page. So this is like an end-to-end test, integration test for your Angular app, and the tool is called Protractor. Okay, so enough of that boring stuff with Angular. Let's talk about 1.3 stuff, like the really cool new stuff that's coming around. Well, with 1.3, what we can do is we can have form validation. And what form validation allows us to do is we can set like the form validation has been around Angular since the early stages, but the new stuff in 1.3 is much more advanced, and we can do a lot more cool stuff. So, if for example we wanted to check to see if a user email field exists, this is what we had before. We can check to see if the email is invalid or valid. Angular will automatically figure out that it's an email, and it's going to place an email validation on it, so the user has to type a valid email. But with 1.3, we can have custom validators that add to our application much easier. So, for example, if we wanted to have something that would check a username if they enter the username characters in the right way, we could do something like this, where we set a directive called username characters validator. We get access to this particular ng model, which is the ng model thing that collects data from the user. And then on there, we add a validator that checks to see if we have uppercase, lowercase, digits, non-normal characters, special characters, and no spaces allowed. And then the actual code to test it is we would just add the special HTML property to it. And here is how we display the message. But what's really cool about 1.3 is we have asynchronous validators, where if we had something that would check to see if a value exists on a server, then it would have to do a round trip from the client side to the server, get the result, then tell our application that we have a failed validation. But with 1.3, we have async validators where we just return a promise, for example, when the when the validation runs. This is what the code looks like for that. We gain access to the async validator's code, and here we're checking to see if the property on the server exists, and it tells us when it's false or not. And once again, to make that work, we would just add in this username available validator to the code, and then here we can specify an error when the username available is false. So back to what I had here, when this happens, both the valid and the invalid flags on the validation code are set to undefined because we don't know what they are yet. And then a pending flag is set so we can have a loading animation of some sort. So here's an example of this in action. So on my blog, here I made a demo application with these new form features. It looks like the internet's, all right, there we go. So for example, if I type in username here, that's fine because I misspelt it. But if I type in username, it's checking to see, now it tells me it's already been taken. I can't submit the form until the user is valid on the server. But I don't have to have this crazy complex JavaScript code that says don't submit unless this is true. It's just a basic validator. So if I choose a username that is free, such as user, then I'm fine. And then I can validate the code. Another really cool thing with this is that there's a system of displaying messages in 1.3, which is much better than we had before. So if you have a lot of form messages like a required validator or a min length or a max length or a pattern, it can get kind of tricky to display the messages accordingly. So what you can do with ng messages is that you can scope your code like this to have this particular username validator, and we can display the messages in order. So we're going to display the required validator first, then if the username has misspelled characters, and then we're going to display the message if it's already in use. So if you've suffered from having too much validation code in your Angular apps, ng messages is really cool because it can really improve the HTML code to display error messages. So you can also put the error messages into a separate HTML file and have them download so that they can be validated against your application. For the stuff that I talked about for forms, there's also something called ng model options, which I recommend you take a look at. In the slides, if you want to see them, then if you click on them here, you can see them, or if you go to my website, Year of Moo, you can see that as well. Okay, so with AngularJS, we have animation support, right, where we can pass in animation hooks like CSS and JavaScript code, which would kick off an animation as it happens. Here, for example, we have a repeater that's going to be repeating stuff, like, for example, the users. We add an ng animate, and then what we can do is we can fade in and fade out stuff. So if I quickly paste this code into the application I have here, and I add in the ng animate module, so I add that down here. Oops, sorry. And we add in the Angular animate code. Now, for the user's code that I had before, if I add in a class of fade, and then let's say that we have it so that we can filter out the users using ng model. So whatever the user types in, the users will will be filtered out. So in this case, the connection keeps dropping. So if I go into the users right here, now if I start typing in stuff, so we gotta add the fade class. The fade class is added. I forgot to copy this upper part right here. So what's happening here is we're specifying a transition, and we have the enter animation that's going to fade in from something and fade out to something, and we have the leave animation as well. So if I copy this code in here, yeah, it's right there. So now for the users page, oh, it's still not working. What's going on here? Did I copy it in correctly? Okay, might be something to do with the connection. That's probably downloading. All right, well, I'll show an example in a moment, but we can add in animation hooks directly into the application. We can also use keyframes, and we can also use JavaScript code to trigger off animations. So with this, we can also, 1.3, we can tell we can have to have multiple animations run at the same time using this tag called ngAnimateChildren. And what we can also do is use promises with the animation API. So instead of having callbacks to fire when an animation is triggered, we can use promises. Finally, a really cool thing with 1.3 is we can pass in hinting. Now this isn't in the core yet, it will come in this week hopefully, but what we can do is we can say when the user clicks on something, that is setting the styles of where the box is going, but we can pass in animation hooks to animate it in whatever way we want. So the goal of 1.3 and 2.0 is to pass animations for every part of the application as possible. So here's what I want to demo with the animation code. Here's a working animation where we're going to load in something called animate.css, which is a third-party library, and then we can add our own animation code, which hops onto it, and okay, where is it? Loading. Give it a moment. So here, for example, we have a library called animate.css. It comes with all these cool animations. Angular is smart enough now to tap into these, and then we can specify a delay in between. So with that CSS code that I had here, sorry, up here, this same CSS code, we can define what animations are run for the enter and leave animations for, let's say, a series of items on a page, and then we can provide in a keyframe which will animate that as well. So if we want to have something like a hinge animation, you can see all these cool animations that we can add into our application. So check out ngAnimate and check out this staggering feature to see how you can use these. Another really cool thing I'll go over quickly is with Angular 1.3 we have ARIA integration. So if you had an application that had ng-show or something like that, it would automatically put the ARIA tags in there for screen readers to understand. And another example is a checkbox where if you check on it, adds the ARIA checked. So it's pretty new right now, and there's only certain directives that would automatically add ARIA support, but this is going to get better over time. Finally, there's a new framework that comes with Angular, or not comes with, but can be used with Angular called Material Design, and that allows you to have really cool effects in your application and to build an application that would work on a mobile phone as a desktop in the same way, and it's built on Google's Material Design framework. So I'm not going to go over this here, but the link right there is material.angularjs.org. And if you look for material polymer or something, you can see really cool demos. Angular's not fully there yet, but soon it will be. Okay, so that was it for the talk, and I hope that you enjoyed looking at Angular and seeing the features that come with 1.3. I can ask if anyone has any questions right now. I'll be happy to answer. No questions? Yes? So the question was, would it take a long time to merge Angular and Polymer? I've never tried using them together. The tricky part is that Polymer is a series of polyfills on top of the HTML5 JavaScript technologies to make sure that all browsers have these new crazy features. It would kind of conflict with Angular. In the future, we might be able to get them to work, but right now, since both of them are kind of in a development stage, I don't think that's really easy right now. I wouldn't really recommend it because the features in both frameworks are kind of similar, but at the end of the day, they're really different. If someone had a question here, sure. So Angular takes care of all that for you. So it keeps an internal counter. If I can find it, here we are. It keeps an internal counter, so it knows which one comes in. So right here, if I type in an invalid user, so if I type in, like, there's no request to the server. All the other validators on the input element prevent the validation from going out. But as soon as I type in, like, a valid username, you can see that it only did one request. But the reason why it did only one request is because I had this thing called ngModel options that I didn't go over, which made it so that there's a 500 millisecond delay until it accepts the value. But you can do that to prevent multiple requests going to the server. But even if you don't have that, and you just start typing in values into the server, so if I type in like 1, you can see that it's doing multiple requests. Angular knows which one to use is always going to be the last one. So this is what makes the asynchronous code much easier to maintain, because you don't have to do all that tricky coding to figure out which request is the right one. Oh no.
Is Angular ready for running in mobile browsers, particularly in regards to performance and download size?
Okay, so
Did you hear that question up there?
So there's been a lot of questions about Angular and how well it works on a mobile browser. With 1.3, it's a lot more performant than 1.2. There's a lot of stuff that we fixed and made faster. And while mobile phones will always be a step down from desktop browsers, it's getting better over time. So if you wanted to use Angular 1.3 with a mobile browser, then you have to read, like, you're fine to use it. There might be some things that might slow down over time if you're not aware of things that will slow down an Angular app, but that also affects desktop browsers as well. In the future with 2.0, it's getting developed as a mobile-first framework. So it's getting developed for mobile phones with a bias towards mobile phones first and then desktop browsers, so that you can use Angular on a mobile phone and have it run as fast as a desktop application.
Okay, so thank you. Next question. What is best practice on organizing the JavaScript code across files? Require JS?
So what you can do is, I had all those controllers and I had all that module code. You can put them into separate files, but you'd still need some sort of tool to put them all together into one file, and you'd use gulp or browserify or stuff like that. I think that's kind of what the question is. If you're wondering about Angular directory structure, if you go on the Angular blog and you look for an article about proposed directory structure, they explain, good ways to organize the JavaScript code to make it predictable and to know exactly where files are.
Thank you. Does the async validate work if you send multiple requests and the server answer requests in the same order?
So I just answered that question again, and
Okay.
it will
Sorry,
handle it accordingly.
I was having problem with my app, so I missed that. Sorry
Yeah.
about that. Then maybe the last one is also already asked. Have you done anything in terms of improving performance going from 1.2 to 1.3?
Well, a lot of the browser incompatibilities, like IE8 stuff, has been removed, so there's a lot less code to fit older browsers. Angular 1.3 has a bind once feature, so if you have one binding that will never change, you can use bind once. And a lot of the internal stuff on like scopes and like when data is destroyed and when data is updated has been updated as well. And there's a new feature that will hopefully come in where you can only digest a particular piece of the application, which once we get that working properly, it'll speed things up much faster.
Thank you very much. And before we thank Matias for his great talk, I would like to remind you to vote. Please vote. Thank you.
Thank you.